Alright guys, so we started our polygons unit throughout this. For polygons, the sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon by connecting one. So we have a table here where we did this. Now you can see here in the triangle we're saying that is 1. Now I know I've had people in the past tell me that I can connect this vertex, I could draw it straight down and look, there's a triangle. You can technically make a bunch of triangles, but it defines it as connecting one vertex to each of the others. So we always start from the same vertex. So looking here at the quadrilateral, the four-sided figure, we see one diagonal, one vertex, the four sides, two triangles. If each triangle is 180 degrees, then the interior angles of a quadrilateral is 360. For pentagon, we have 5 sides. We can draw 3 triangles within that shape by connecting one vertex to each of the others. So the interior angles comes to 540. Hexagon, we add a side, we add a triangle, we add 180 to the sum of interior angles, so we get 720. And you can continue on this chart. Notice we didn't have pictures of heptagon, octagon, nonagon, decagon. We just know that they are 7, 8. So for a heptagon, the interior angles is 900. For octagon, the sum of interior angles is 1080, nonagon is 1260, and decagon is 1440. Now, above decagon, we're not expecting you to memorize these, and from there on, you'll notice here in our examples, they have 15gon. They'll just put the number of sides and then the suffix gon. So to find the interior angles of any shape, you're going to take n for the number of sides, and use the formula sum of interior angles, S, is equal to 180, the number of the degrees inside a triangle, n minus 2. Number of sides minus 2 is the number of triangles we can form. So every triangle times 180 gives me the total sum. So for 1, 2, 3, and 4 here, we took the number that's in the front, 15gon, 21gon, 48gon, 36gon, and we substituted that number into the formula. So for 15, we plugged in 15 for n, and we multiplied by 180. So 180 times 15 minus 2 is 2,340. 21, we have 180 times 21 minus 2 is 3,420. 3 and 4 we did not do in class. You do not have to have them in the filled-in version of your notes, but we did the same thing here to get 8,280 and 6,120. All we did was run it through a calculator, just like we do for all of the other problems. 15 minus 2. Exactly what we typed onto the screen in Kami, we can put into Desmos. So if we have a regular polygon, regular polygons are polygons where all the sides are congruent and all the angles are congruent. So to find a single interior angle of a regular polygon, all you have to do is take the sum of the angles and divide it by the number of sides. So the formula for the sum for a single interior angle of a regular polygon is S over n, or substitute in the formula for S 180 times n minus 2 and divide all of that by n. All you have to do is run the number through the formula. So for number 1, we had S is 540 because it was regular pentagon. N is 5. We took 540 divided by 5 and we get 108 degrees. For the regular 18gon, we don't already know what S is, so we'll just take 18 and plug it in to 180 times 18 minus 2, all divided by 18 to get 160. So that's our interior angles. What about exterior angles? Just like when we did exterior angles for triangles, it is the supplement to the interior angle. Remember, supplementary means that the two angles add up to 180. So what we did here for the triangle, and we show it, is we did the 180 minus the interior angle to get the exterior angles. So that 180 minus 61 is 119, 180 minus 79 is 101, and 180 minus 40 is 140. We added those results together. 119 plus 101 plus 140 is equal to 360. We did the same thing for the quadrilateral. The supplement of 71 is 109. The supplement of 124 is 56. The supplement of 76 is 104. and the supplement of 89 is 91. Add those four numbers together, 109 plus 56 plus 101 plus 91 will be equal to 360. You'll notice we did the same thing for the pentagon and hexagon and found that the sum of exterior angles of a polygon is always 360 degrees. For a regular polygon, what you can do is divide the number of degrees, 360, by the number of sides to get a single exterior angle. Or, if you're given an exterior angle, you can use that information to find out how many sides it has. So for a regular hexagon, we have 6 sides. 360 divided by 6 is 60. And then we have number 2. We have the measure of an exterior angle of a regular 24gon. So 360 divided by 24 is 15. And then if we have the measure of one angle, which is 12 degrees, we can find out by dividing 360 by 12 that there are 30 sides to this figure. Now, if you're given one interior angle for a polygon, you can subtract it from 180 and find the exterior angle that matches, and then divide 360 by that number. So that's the basic intro to polygons. Up next, we will be talking about two kinds of quadrilaterals.